Comparison between simple pendulum and conical pendulum. Let me explain this in detail. Discuss the comparison between simple pendulum and conical pendulum. You can see here that in case of simple pendulum, the bob oscillates along arc of a circle forward and backward. In case of conical pendulum, bob of the pendulum revolves in horizontal circle along its circumference. In simple pendulum, of course, the bob is in simple harmonic motion under certain condition. In case of conical pendulum, the bob will be in uniform circular motion under certain condition. Here, if we consider L as a length of pendulum, and in conical pendulum also L is the length of pendulum, then the time required for one oscillation in case of simple pendulum is it's called as period. While in case of conical pendulum, the time required for one complete revolution is called as period of the conical pendulum. The period of the simple pendulum is given by t equal to twice pi under root of L upon Z, where L is length of the pendulum. In case of conical pendulum, period T is given by twice pi under root of L cos theta upon Z. Again, L is length of the pendulum. Theta is angle bent by the length with the vertical. Here G is acceleration due to gravity, not only in simple pendulum but in case of conical pendulum as well. Thus we can say that period T is directly proportional to square root of length of the pendulum because it is that numerator. Same is the case in case of conical pendulum. Period T is also directly proportional to the length of the conical pendulum. Talking about the acceleration due to gravity G, here period T is inversely proportional to square root of acceleration due to gravity. Same is the case of period T in case of conical pendulum, which is also inversely proportional to square root of acceleration due to gravity. Here, the period T is independent of mass of the pendulum, of the bob. In case of conical pendulum also, period T is also does not depends upon mass of the bob. One extra thing which is I would like to discuss here. In case of conical pendulum, period T is also directly proportional to square root of cosine of angle theta, which is in between the length of the pendulum and the vertical. If we consider about the frequency n, which is equal to reciprocal of period, also in case of conical pendulum, frequency n is also reciprocal of period, then all these terms means frequency will be inversely proportional to square root of length. Frequency will be directly proportional to square root of acceleration due to gravity, not only in case of simple pendulum but in case of conical pendulum as well. Both the case arises in case of conical as well as simple pendulum. The extra thing about the conical pendulum is that frequency n is inversely proportional to square root of cosine of angle theta. This is because We know very well that the frequency is reciprocal of period, therefore it is given by n equal to 1 upon twice pi under root of g upon L.